All right, so we're going to talk about balancing equations today. I'm going to try to do this on the tablet. See if it goes well. We're going to talk about balancing equations. Let's start out with an easy example. We're going to go H2. That is not a pencil. There we go. We got H2 plus Cl2 yields HCl. All right, so this is H2 plus Cl2 gives us HCl. And how I would recommend you do this, I'll change colors. How I would recommend you guys do this is by writing the elements that you see up here. So you see H's up here, and you see Cl's up here. And you don't have to know at all what those things stand for. They stand for hydrogen and chlorine. Chloride? Chlorine. But you don't have to know that. They can just be some random variable. And so what you're going to try to do is you're going to try to balance one side over here with the other side. The left side with the right side. And this is a Cl. I know it looks like a backwards D, but it's a Cl. And let's review real quick. This H2, that H2 means that there are actually, there's a hydrogen and a hydrogen. And that is one molecule. Two hydrogen atoms is this one molecule. And then you have a Cl, I'll draw it a little bit differently, and a Cl. And that is one molecule. And then you have HCl, which is actually, it looks maybe something like this. And that is one molecule. So you're not going to be able to change, the subscripts. This 2, the one that is here that you can't see, or the one that is here that you can't see. You're not going to be able to change those, but what you can change is how many of these molecules. You'll be able to change the number that'll be before here. So let me go ahead and draw a little line for you. Right there. You'll be able to put numbers on those lines. You can put 5, 10, 1,000. It's not going to get that complicated. It should say single digits for most of them. But yeah, that's going to be that's what we're actually, let me erase all this. So we got H2 and Cl2. How many H's are on the left side? Who can tell me how many H's are on the left side? 2. How'd you know that? Right, because there's a 1 right here, right, that you can't see. There's one H2, and so that means there's going to be an H and an H, and they're stuck together, exactly. All right, so there's 2. How many Cl's are there, everybody? 2. That's pretty easy, right? How many H's are on the right side? 1. And how many Cl's are on the right side? 1. Can anybody see how this is going to go? Is this going to be really complicated? Nope. What do? Do I put a 2 right here? If I put a 2 right there, how many H's would now be on the left side? There would be 4, and that's not what we want. All right, so what do we got to do? Yeah, this reaction is going to make 2 HCl's, hydrochloric acid, I believe. So we're going to mark that through. This is going to be a 2. Mark that through. That can be a 2. Or if you want to erase, then you can erase. But now, is it balanced? Do we have how many hydrogens on the left? 2. How many on the right?
2.
How many chlorines on the left?
2.
How many chlorines on the right?
2.
Balanced equation.
Yes.
Perfect. All right. Let's try another one. I think we did this last week. H2. Oh, let me give some room. We have H2 plus O2 gives us what? What does it yield? What does it say? It's on your piece of paper. I'm getting this from your piece of paper. What's it say? H2 plus O2 yields what? H. Ooh. H2O. All right? And these are the spaces that we're going to fill up right here. We're going to see if we need to put any numbers in those spaces. All right, so what are the elements that we have? What elements do we have? What atoms are in this equation? Yep, hydrogen and oxygen. But you don't have to know that. You just need to know that there's an O and then there's an H. All right, how many hydrogens are there on the left? 2. You can tell that by this little subscript. There's one hydrogen atom, or one hydrogen molecule. So that means one molecule times 2 in each molecule. That's 2. All right. How many are on the right? 2. How many oxygens on the left? 2. How many oxygens are on the right? 1. If there's not a number, you know that you could write it like that. It looks kind of goofy. That's like if you ever have used a measuring tape and you said 4/8 of an inch. Is 4/8 of an inch the right way to say that?
No, it's whole.
It should be half an inch. 4/8 simplifies into 1/2. Or if I said, what's an example? If I said, hey, can you go bring me those 4 quarts of milk? Do you call it 4 quarts of milk? What do you call it?
A gallon.
It's a gallon. It is 4 quarts, but that's not what we call it. Or if you said, give me that however many ounces of milk, please. No, you just say a gallon of milk. You're not being wrong. It's just weird. So you can write that 1 at the end there, but it's kind of weird. But some of y'all really enjoy being weird. Am I right?
Yes.
Yes. All right, so if that's what you want to do, that's fine. Just don't confuse yourself. All right, what do we need to add stuff? We need to add stuff on the left or the right?
Right.
On the right, because the left side has the higher numbers, the right side doesn't. So we need this O to be a 2. How can we make that O become a 2? Anybody? Do what? Put 2 where? Right here. Now remember, we can't, it would be great if we could just do this. That'd be like if somebody gives you a check for $100, $100.00, it would be great if you could just remove that decimal point and just like have, what would that be, $10,000? That'd be nice, but that's just not how it works. You can't put the 2 there. You have to put the 2 as a prefix to the H2O. Because remember, this is a molecule. You cannot change these molecules. You can change how many of them there are. But if you were to add a 2 right there, an H2O2, that actually makes peroxide. Water is good for you, right? You drink enough peroxide, it will kill you. So it's kind of a big difference. It's a drastic difference between H2O or H2O2. So now what do we have? How many hydrogens are on the right side? 4. Dang it. All right, now we got 4. How many oxygens are on the right? 2. Hey, that makes us happy because now they're balanced. You got 2 and 2, but we don't have equal hydrogens. All right, so now what do we do? Yeah. What do we do? Y'all just tell me. You add 2 to the left. Where? Right here? You need to add, we want to say we have 2 hydrogen molecules. And so now we've got 2H2. So how many hydrogens do we have on the left now? We have 2 times 2, which is going to be 4. Hey, we're balanced. 4 and 4, 4 and 4. So the answer to this one, you would have a 2 and then a blank. Or if you want to put a 1 there, you can. But it's going to be blank and then a 2. Y'all get it?